Good afternoon, everyone. Today we're going to do a quick quadratics problem. So we have a quadratic function with a vertex at the point 1, -8, and also with a y-intercept at the point 0, -6, and we are tasked with finding the roots. So first things first, anytime we're given the vertex of a quadratic, we know we can start writing its entire function in vertex form, right? So that means a times x minus the x coordinate of the vertex. For us, that means x minus 1, all squared, and then plus the y coordinate of the vertex. For us, that is -8. Now, anytime we have another point, here it's the y-intercept, but it doesn't necessarily have to be. It can be any other point on the curve. We can use that point as an ordered pair of x and y coordinates, and we can fill those in for x and for y, respectively. And so if we do that, -6 takes the place of y, and we have a times 0 takes the place of x, 0 minus 1 all squared minus 8. And now you'll notice that this is an equation with only one variable, and so we can solve for a. We'll have -6 is equal to a times, that's -1 squared, -6 is equal to a times -1 squared is simply 1. And so -6 is equal to a times 1 is simply a minus 8, and then of course, I'll be nice here and show my algebraic steps. We add 8 to both sides, and of course we find that a is equal to +2. And so now we can write this more specifically as the function y is equal to 2 times x minus 1 squared minus 8. Now, there are a few different strategies that we could use to find the roots. You could look at the pattern of over 1 up 2 over 2 up 8 and so on and so forth. Or what we can do is we can convert it from vertex form into standard form and then factor it, finding the roots. So to do that, we're just going to expand this x minus 1 all squared. So we'll have y is equal to 2 times. Remind you that x minus 1 all squared means x minus 1 times itself, which means we use distributivity to expand that out properly. So we have x times x is x squared, x times -1 is -x, -1 times x is minus x again, and -1 times -1 is +1. So that gives us x squared minus x, it means minus 2x, and a +1 at the end. And so I'll write that as x squared, minus 2x plus 1, like so. And then, not forget the minus 8 at the end. Now we can multiply through all of this. And so we have 2x squared minus 4x plus 2 minus 8. We can combine the constant terms at this point. Plus 2 minus 8 means -6. And now you could factor using decomposition, or you might recognize that all of these terms have a factor of 2. And so we can factor out that 2 and be left with 2 times x squared minus 2x minus 3. And now we can factor the quadratic inside of those brackets in a more simple manner by thinking what two numbers multiply to make -3 and simultaneously add for a sum of -2. You might find those numbers jump out at you, and they turn out to be -3 and +1, and so we can factor as x minus 3 and x plus 1, -3 and +1 being the two numbers that satisfy the two conditions above. And so now we have y is equal to 2 times x minus 3 times x plus 1 as our equation in factored form, right? We call this factored form. And so if we're looking for the roots of any function you'll ever work with, the roots are found where the y coordinate is 0, right? When we're on the x-axis. That's why we call roots x-intercepts interchangeably, right? And so x-intercepts or roots are when y is equal to 0. And so let's set that y to be equal to 0. And so we have 0 is equal to 2 times x minus 3 times x plus 1, right? Setting the y equal to 0 and the right side as it was. And now we have the null factor law that if 0 is equal to something times something times something, then one of the things themselves have to be 0, right? You can't multiply non-zero values, have a product of 0. And so that the 2 can't be 0. So that means that either this factor is equal to 0 or this factor is equal to 0. Of course, if x minus 3 is equal to 0, then x is equal to positive 3. And if x plus 1 is equal to 0, then of course x is equal to negative 1. And so that means that our roots are found at, because roots are still points on a graph, so they should be written down as coordinate points. They should be written down as negative 1, 0, and at 3, 0. And that I would leave as our conclusion. And so there we go. Again, there's probably another way to go about it. If you're comfortable using the patterns of over 1, up 1, over 2, up 4, multiplying however we rise by the a at the very front, you can do those as well. Those are often helpful, but this is a more algebraic approach. And so I hope that helps, and thanks for watching.